Good morning to Dr. Chiu. We are Group 3. So today we are going to present and show the output simulation from the Maria application. So this is our team, which is Haziq and me, Shami and Iman. So I will pass to Iman to explain about the introduction.
About introduction, in the world of computing, the act of computer carrying out a program or set of instruction is known as execution. Execution is the fundamental mechanism through which computer carry out operation, handle data, and generate result. Execution is centered on the central processing unit, which is CPU, or processor of the computer, sequential interpretation and application of instruction. These instructions are frequently expressed in a program language and then converted into a machine code, a low-level representation that a computer can understand and carry out by compilations or interpolation. The program execution process starts when it is loaded into the computer memory. The first instruction is a read from memory by the CPU, which then decode it into determine the specific action that has to be carried out before executing. Each new instruction is followed by a repetition of cycle until the program is complete in order to access and manipulate data as necessary during execution. The CPU interfaces with the other computer parts such as memory, input and output unit, and storage. Instruction can contain arithmetic and logical operations, data movement, conditional branching, and a verifier of additional action, depending on the program and its goal. The two types of executions are interpreted execution and compiled execution. To run a software in interpret execution and interpret read and run the instruction line by line. Even though it takes longer than compiled execution, this method offers more flexibility. In compiled execution, a compiler completely transforms a program into machine code before it's performed. This translation process makes the application more efficiency and create an executable file that the CPU can use to run the program immediately. Although compiled execution is frequently quicker than interpret execution, it does not allow for program modifications while it's in use. This idea of execution in computer is fundamental to computing because it enables the conversion of instruction into useful output and activities. It is a fundamental method that gives computer the ability to perform a variety of activities, from straightaway computations to integrated simulations, data processing, and other jobs. Alright, here the assembly code. Alright, so firstly we input and then we store the value of the accumulator in memory location C, and then we store the value of accumulator in memory location E, and then we store D in memory location D, and then store the value of accumulator in memory F, and then store the value of accumulator in memory location G, and then we load C, which is load the value of memory location C into the accumulator, and then we add the value of memory location E into the accumulator. We store X, and then we load D. We sub F, which we sub the value of memory location F into the accumulator, and then we sub G, store E, load Y, and then we sub X, we sub the value of memory location X into the accumulator, and then we get the output, and then we halt is stop execution, and then C is DAC 0, E is DAC 0, D is DAC 0, F is DAC 0, G is DAC 0, X is DAC 0, Y is DAC 0, and A also DAC 0. Alright, the DAC meaning is instruction is used for decrementing an operand by 1. It's work on a single operand that can be either in register or memory.
Okay, hi, my name is Muhammad Aziz Hakimi and this is Mary.js program simulator. So we create our equation, then from equation we create the coding. So this is our equation: y equal to in bracket c plus e close bracket minus in bracket d minus f minus g close bracket. So from the equation we make a program, and this is our program, and let's run. So we make it easier to put any value. It's better than we put a current value that can't be altered. So if we this program, we can alter any kind of value. So first, this is value for C, E, D, F, and G. Then we put the value. Let's put 1 plus 1, 1, and for F equal to 1, G equal to 1. So this is the value from our equation. So C plus E we put in X register, and D minus F minus G put in A register. So X minus A equal to Y. So Y we get 3. This is 3. Then this is our register memory, and start with 1 because we start with origin 100 origin, and 5000 is our memory for input, register for input, and store C label address 116 5000 for input, 117 118 119 G 11A. So this is the value that we put when they ask to put the value equal to 1. This is for output. Then we get 3 for decimal, and for hexa 003. So for instrument register we get 7000, and same as master boot record 7000. And our accumulator we receive the result from our coding, so we will get accumulator will get 0003. Okay, so what if we restart and run? Okay, we put another value. So if we put 6 for E, for D 6, for F 6, for G 6, then we get the value. We put in decimal 18. So the value after we calculate using calculator, we get the result same 18 from our equation. Okay, and this is the result FFFA 00112. Okay, that's all from me. Thank you.
Good morning to Doctor. My name is Muhammad Syamil, method number CE228. So I will continue this explanation. So the equation we use is y equals c plus e minus t plus d minus f minus g. So we put x for c plus e, and then we store the y is d minus f minus g. So first of all we run, and then we put the example value, which is we put the 5 value for store C, and then plus E we put the 5 also, and then another value for store D we put the 5, and then F also 5, and G also 5, and then we can get this our solution in this our webs, which is the same like a manual calculation. So this is our decimal output, and this is our hex, and then this is a binary. And then so we can see from the RTL log, we can see the decode opcode 5 in IR, which has the input. And then for this is our store C, which is 2 in IR. And then this is for inputs, the same 5 IR, and then this is a 2 in IR. She has a store. Then they also input are 5 in IR, and this is store D, and this is input. This is store F. Then this is input also. This is store G, and then we load C, and then add E, because we want to minus the equation. So this also for store X, which is from C minus C plus E. From we put the X, and then for Y, store Y, we store Y this one. We put the Y, which is E minus D minus F. Okay, this is our coding. So we go to the view data parts. This is our what we call our circuit. So if you want to see in detail, we can put the more delay, and then we so the input we get is 116 for which is the machine halted normally. So basically is okay lah for this circuit. So we can see the IR is 7000. For outs is 00F, which is from the hex output, and then for input 005, and then AC is 000F. So the so connect to the ALU, and then go to MBR is 7000, and then PC 116, and they go to MAR is 115. I think that's all for me, and thank you.
Alright, for the conclusion for this project, utilize Mary.js to visualize data and instructions, simplifying code analysis and debugging. By executing assembly language equation, user can gain knowledge, consolidate knowledge, and exchange their skill in evaluating and designing computer systems.